Okay, so here we are going to graph this parent function, this equation, which has been transformed. Transformations have been applied. So transformations is the more broad general term. And we're describing things like out here, this is a vertical reflection. This 2 right here represents a vertical stretch of 2. This -5, so those are types of transformations. So transformations under that umbrella, reflections, stretches or compressions, could be vertical or horizontal. -5, I don't know if any of you remember what this -5 does to the graph. What do you remember? Go ahead if you want to shout it out. Jeremiah, you remember?
It's supposed to move it like the number of places. I think it's supposed to be positive 5 places.
So yeah, so 5, so is that 5 up or 5 right then with the positive?
Right.
Good, yeah. So you remember that correctly. So I'm just describing over here my transformations. Transformations as I go. Hopefully you guys got this all right. Then we said there was a vertical. I'm a stickler about spelling vertical correctly. Vertical stretch, because it's larger than 1, so it's a stretch of 2. Then it moved to the right 5. Does anybody remember what +8 does? You could just shout it out if you think you know.
Does that go on the y-axis?
So it goes in the y direction. And what were you saying, Victor? Sorry.
Intercept is like where it starts on the y-axis.
So yeah, it's kind of like how Anna was phrasing it too. I wouldn't say it's necessarily on the y-axis. It would be if you remember standard form. That's when it's like ax squared plus bx plus c. That last number is your y-intercept. But when it's in this form, does anybody remember the name of this form? It's not standard form. What form is this in? You could shout it out because I kind of have my view is sort of like obstructed, so it's hard for me to see if you raise your hand. It's not standard form, it's blank form. Because you could easily see the blank.
Kiara said exponential.
Oh, yeah. A lot of people think exponential. That's a common thing that people think here. I'll point something out with that too. It's actually, this one's called vertex form. Now, I'm glad you actually mentioned that, Kiara, because I forgot how there's a little mix up with that sometimes. So when we have a number, like a constant, like 2, 3, 4 as the exponent, those are actually called power functions. And then and the variable is here as the base, like x. When it's the other way around, okay? So for example, I'm just going to grab a scrap piece of paper. If instead it were something like 2 to the x power. If it were this is called an exponential function because it has an exponent, right? But then this x to the second is a type of power function because 2 is the power. So it's a little confusing because like it seems like, well, this word makes sense for this too, but the vocabulary that we use is a little different in this case. But that was a good word to bring up though, okay? But the name of that form is vertex form. And I'm going to write this down. I think this is important. Y equals, I'm going to put in A parentheses. Now I'm going to be very generous with my parentheses right now. B, another parenthesis, X minus H, close, squared, plus K. So the H and the K moved me right 5, and then the K moves us. So remember, it doesn't mean that my graph is on the x-axis at 5. So you guys were kind of phrasing this funny. Maybe you drew it correctly, but you might have just been saying it a little strange. The +8 moves your graph. Nobody else wants to go for it before I say it. The +8 moves the graph. You can just shout it. Go ahead.
I can try. Can I try?
Yeah, anyone. Go ahead. Sammy, you want to try it? Go ahead.
it moves it up 8.
Yes, it's just going to be
Or-
up 8. And by moves it, one of the main things that it's moving in this case is the vertex. Sometimes it's not the vertex because, for example, the one function you guys mentioned before at the beginning of class, you guys said like rational or reciprocal, that one that had the 2 branches. The point that's moving is really where the 2 dotted lines cross. Ooh, does anybody remember the fancy word for those dotted lines? It started with an A.
Asymptote or whatever.
Yeah.
I don't know.
Good. No, you're right. You got it. Asymptote. Good. So the asymptote is what moves instead of the vertex. Okay. So hopefully this is like jogging all your memory. What else could I write down? I just want to look at what I made for my request of these little notes here. Okay. So let's kind of get this going. Now, here's one of my little hacks for graphing. One thing that stinks is that you draw your X and Y axes and then you go to put your graph on it and you're like, ugh, I don't have enough boxes, right? Worst thing ever. So we're going to cheat and kind of do it a different way. What we're going to do is I'm going to plot my vertex in a convenient spot, draw my graph, and then I put my axes in after. Now, since there's a vertical reflection, normally this graph, Morgan used the word before, parabola, it looks like kind of like this, right? Like a curve like that. The vertical reflection is up and down vertical. It flipped it up, down this way, right? So it's going to have this shape to the graph. So from there, we're going to have a point at the vertex like this. It'll be the highest point in this case. And my graph will be going down like this. So I'm just going to put it there because nothing will be above it. Now, does anybody else remember the way to figure out where all the points go without making a table of values? I know I teach a trick. I don't think every teacher does this, but there is a trick from the vertex where we can go out and down and kind of plot this little breadcrumb trail of points and make a really nice graph. So maybe your teacher did go over it. So I have a couple hands pop up. So let's try Sammy first.
Isn't it when you like move to the right, like it says, or move to the left, and then you go down, and then that's where you would plot your next point?
But do I just go down one, out one, down one, and go straight?
Doesn't it have to do with your vertical stretch?
Okay, it has to do with the stretch. So she's remembering things. Good.
You go 2.
Which, okay, so there's like a 2 involved. You remember you implement the stretch. You're right. Emerson, do you remember anything else about it?
There was like a certain set of numbers that you would always multiply by. So I'm pretty sure there was like 1, 3, like 7,
1, 3,
7, 5,
then
and 7.
yeah, it was the odds. So here's a fun fact about x squared. If you ever made a list of all the perfect squares, 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared, 16, and so on. If you keep going with this list and then you give this to like a 10-year-old and you're like, what's the pattern? The 10-year-old is going to be like, okay, you add 1, then you add 3, then you add 5, then you add 7. So a high school student, if I gave you this list, you might be like, oh, it's all the perfect squares. A 10-year-old is not going to know that those are perfect squares. I thought they would. I tutored a little kid once and he did not know. And I was surprised because I don't teach little kids. So this 1, 3, 5, 7 is like your magic pattern for parabolas. Remember that. It's your pretty perfect pattern for parabolas. What's that called when it's all the same letter? Alliteration, I think. Maybe. So Sammy mentioned that we have to bring up that -2. So instead of going out 1 up 1, out 1 up 3, out 1 up 5, out 1 up 7 for a parent function, we're going to use our pretty parabola perfect pattern. And it's all these odds, but we flip it. So we're going down and we stretch it. the out 1 is still going to be out 1, but the down 1, down 3, down 5 is going to be doubled. So we're going to go out 1, down 2. And I'll go more into this next time, all right? You may not have graphed this way last year, so I think it'll make your life easier. Out 1, now, normally the next one was, so it was 1, but I doubled it. 3, but I'm going to double it. So if I double 3, I get 6. Out 1, down 6. Is that what you're saying? So you said 6? So yeah. So the 1 stays 1 every single time. We move over to the next number and square it. We move over to the next number and square it. Next number and square it. And how far apart is it? They would normally be odds. Now the next one would normally be 5, but I'm going to double it. So I'm going to go down, out 1, but down 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, now I have this beautiful set of dots on my paper, and then I'm just going to connect them as best as I can. I hate when that happens. This is where I bust out my nice erasable pens usually, so I don't make a mess. Oh boy. Now, to be cheap, this is where you go in and you put your axes in after. So if it was to the right 5, that means right 5, I moved right 5. My y-axis is actually left 5. So from here, I'm going to go 1, 2, 3, 4, 5, and I'm going to draw my y-axis. Don't put arrows on until you know where they need to go. And now if it was up 8, from here I'm going to go down 8. 1, 2, 3, 4, 5, 6, 7, 8. Now what has happened is instead of you drawing too much of like quadrants 2 and 3 or something like that, we draw the graph and then we draw the axes after, so we have exactly what we need. So there's X and Y. Now, another thing that's easier is this is going to be able to, you could get your X and Y intercepts right from the picture if you wanted. You can describe now increasing and decreasing domain, range, and all of that other vocab from Algebra 2. We can describe it from the picture instead of like struggling and making a table of values. So what I can give you guys for an assignment for homework is I can kind of give you maybe like some kind of like a matching multiple choice type of thing. If you guys had me last year, remember we did the paper where you guys had to like match the picture and the equation kind of thing, but I could give you like a virtual version of that where you match equations to their picture based on the stretch and compression, maybe like a multiple choice thing. And hopefully that helps you remember how to graph. Would you want something like that? Like, or do you want to actually practice drawing on paper? What do you think is better, more beneficial?
The first time.
The first, you just want to kind of practice matching and recognizing the parent functions and the transformations first to get started. Okay, so we're going to spend maybe like one more class on this, and then we're going to go into graphing trig after that. So that's the end of this little video here. I will share though a couple other videos. So if you think you're weak at graphing, you might want to check them out. I think the people who spoke up a lot today, I think you do guys remember a lot. So good, great. Give yourself a pat on the back. That was very good because that was a long time ago, like a year ago. So good job. And just check Classroom. I'm going to probably post something later this afternoon. I have another class now, office hour, and then I'm doing the Twilight program. So somewhere in between there, I'll post you guys some homework, okay? But thank you, big participators today. You were great. Much appreciated. And I'll see you guys next time.